This is where life began. A living space with freedom to move in all directions, where the distances are beyond our imagination and the possibilities for discovery are endless. But what we see can be deceiving. Our oceans may not stay this way. Scientists now know that our seas are growing more and more acidic, faster than predicted. Rapidly rising levels of CO2 in the atmosphere are lowering the pH of seawater in many areas of the world. Marine life is endangered.
The levels of acidification that we've reached today, they don't have precedents over maybe 20 million years. And the levels that we will reach by the end of this century might have no precedents of over at least 40, 50 million years.
Our hunger for burning fossil fuels is causing an alarming increase of carbon dioxide in the atmosphere. Not only our climate, also our oceans are affected. More and more CO2 molecules are entering our seas. As the CO2 molecules react with the seawater, hydrogen ions are released. And the more hydrogen ions in our oceans, the more acidic the water. High water acidity, in turn, will affect carbonate ions. But carbonate ions are needed by many marine organisms as vital building blocks to form calcium-based skeletons and shells. The more acidic the ocean becomes, the more carbonate ions will be tied up by hydrogen ions, until carbonate ion concentration in the water becomes too low for calcifying organisms to remain healthy. Scientists around the world are shedding light on how ocean acidification can influence the health of marine life. And corals are in the focus of many investigations. In laboratory experiments, CO2 was released directly into the aquarium to make the water as acidic as it is expected to be in our oceans by the end of this century. With time, some corals slowed down their growth, while others even stopped developing calcium skeletons.
Our results of our experiments on ocean acidification in the laboratory, at the moment, the ones we've run with corals, they all indicate that corals will calcify less in the future due to acidification. And we've checked that with different species, and they all point towards this direction.
In some ocean regions of the world, already by the end of this century, the concentration of carbonate ions might be too low to support the formation of calcium carbonate skeletons and shells. The levels of acidity in these waters could become so high that carbonate skeletons and shells of calcifying organisms would start to break up and dissolve. This destruction of coral reef ecosystems could have devastating effects on marine life, because many organisms depend on coral reefs for food. Without coral reefs, much familiar marine life would vanish. Predictions about potential effects of ocean acidification on marine life are not only based on laboratory experiments. Scientists are also studying such events up close in nature. Off the island of Ischia in Italy, underwater volcanic vents release large amounts of CO2. Here, it is natural acidification that helps scientists to take a look into the future. Far away from the volcanic vents, at a safe distance, researchers discovered the waters to be full of life. This far from the vents, they also observed calcifying organisms growing on seagrass. But as they gradually drew closer to the volcanic vents, these calcifying organisms on seagrass disappeared. And even closer, the acidity of the water became so high that corals, mussels, and other living organisms could no longer cope. Natural volcanic vents, therefore, help us to see what some areas of our oceans may look like by the end of this century. Ocean acidification has already begun to challenge our seas on a global scale. With increasing carbon dioxide in the atmosphere, marine waters are turning more acidic. At the poles, because CO2 dissolves well in cold waters, but also in tropical regions, where coral reefs are located. Even if we stopped pumping CO2 into the atmosphere, acidification of the seas would pose a serious threat to marine life. Our oceans are finite in what they can give and in what they can take. Their capacity to protect their inhabitants from human excess is limited. Marine life may not always be able to cope with the sheer speed of change caused by man.